Imagine winds blasting at 250 kilometers per hour, the ground shaking so violently it flattens entire city blocks. And right in the middle of all that chaos, a 500-meter tower of glass and steel just stands there, not cracking, not crumbling, not falling. How is that even possible? Today, we're going to break down the engineering magic that lets skyscrapers survive what destroys everything around them. First, let's understand what exactly threatens a skyscraper. During a hurricane, a building faces enormous lateral pressure, and the higher you go, the stronger the wind. At 400 meters above ground, wind can be 4 times more powerful than at street level. It's not just a push, it's a relentless sideways force trying to topple the structure, like a giant hand slowly shoving a stack of books. An earthquake is a different story entirely. The ground moves horizontally, fast and chaotic. The base of the building moves with the earth, but the top, due to inertia, wants to stay put. This creates the whip effect. The taller the building, the more violent the snap at the top. Hundreds of meters of steel and concrete try to swing like a pendulum, and if the structure can't handle it, it fails. The first line of defense starts where you can't see it, underground. Skyscrapers don't just sit on the surface, they literally root themselves into solid rock. Beneath most skyscrapers, there are hundreds of concrete piles, up to a meter in diameter, driven 30, 50, sometimes 80 meters deep. They reach all the way down to bedrock and hold the entire structure, the way roots hold a tree. Even if the soil around them shifts and liquefies during an earthquake, the skyscraper stays put, because its legs are anchored in immovable stone. Now let's talk about the frame itself. And here's a counterintuitive fact that surprises most people. Skyscrapers are not supposed to be rigid. They're supposed to flex. A properly designed skyscraper actually sways during strong wind or an earthquake. Literally, the Empire State Building sways 2 to 3 centimeters. Taipei 101 moves up to 60 centimeters during a typhoon. The Burj Khalifa up to a full meter. And that's not a problem, that's the plan. A rigid structure stores stress until it snaps. A flexible one dissipates energy through movement. The steel frame behaves like a living tree. It bends, but doesn't break. Engineers carefully select steel alloys with shape memory, materials that return to their original form after deformation. Built to bend, built to survive. Now here's the coolest part, the one that sounds like science fiction. Inside many skyscrapers, there's a giant pendulum. It's called a tuned mass damper. Essentially, it's an enormous metal ball or disc weighing anywhere from 400 to 1,000 tons, suspended on cables, or mounted on a platform with hydraulic shock absorbers. Here's how it works. When wind pushes the building to the right, the pendulum, due to inertia, stays behind, meaning it moves left relative to the building. That counter movement cancels out the oscillation. Taipei 101 has a ball weighing 660 tons, 5.5 meters in diameter, a golden sphere hanging between the 87th and 92nd floors. It's not just engineering, it's art. They literally turned it into a tourist attraction. What's fascinating is that some modern buildings skip the ball entirely and use giant water tanks instead, liquid dampers. As the building sways, water sloshes to the opposite side and dampens the movement. Simple, but brilliant.
The shape of a skyscraper isn't just about aesthetics. It's aerodynamics. Wind hitting a flat wall creates maximum pressure. But if the building has rounded corners, a tapered silhouette, or a twisted form, the wind slides around it and loses force. The Burj Khalifa narrows as it rises and simultaneously twists. That's not a design choice. It's an engineering solution that cuts wind load by 25%. Some buildings go further and have openings punched through them, like the Shanghai Tower.
Wind passes through instead of pushing against the structure. Because the most dangerous effect during a hurricane isn't the raw pressure, it's the vortex shedding. As wind wraps around a building, it alternately pulls it left and right at a resonant frequency. That vibration can be lethal. The right shape breaks that resonance entirely.
None of this is theoretical. Here are real cases.
2011, Japan. A magnitude 9.0 earthquake, the strongest in the country's recorded history. Tokyo shook for several minutes. Cameras caught skyscrapers swaying slowly back and forth, office furniture sliding across floors. But not a single high-rise collapsed. Not one. Japan pours enormous resources into seismic engineering, and that investment paid off in millions of lives saved. 2017, Miami. Hurricane Irma, Category 4, winds at 210 kilometers per hour. The city was evacuated, and when the storm passed, news crews flew helicopters over downtown. The skyscrapers were intact. Some lost glazing on lower floors, but the frames, foundations, structural cores, zero damage. And finally, Taiwan. Typhoon Soudelor, 2015. The most powerful typhoon in 50 years, winds exceeding 220 kilometers per hour. Taipei 101 didn't just survive. Sensors recorded the mass damper swinging 100 centimeters, absorbing every oscillation. The system performed perfectly.
Skyscrapers don't fall because thousands of engineers spent decades teaching them how to breathe, to bend without breaking, to absorb a blow instead of resisting it. That's the paradox of modern architecture. The bigger and heavier the building, the more it resembles a living system, with reflexes, memory, and the ability to adapt. Next time you look up at a skyscraper, remember, inside it hangs a pendulum keeping it upright. Beneath it, piles drilled down to bedrock, and its shape was sculpted not by an artist, but by the wind itself. If you found this interesting, subscribe and hit like. Next video, how bridges support their own weight of several billion kilograms. See you there.